Holy smokes, there's a lot of people here. Hi, guys.
What's up, Mark?
She said more people should come to talk about the list. So we're auditing your.
What was that, Matt?
Casey said we should all come to listen to the buffer list conversation. So.
Oh, I think Casey's running the buffer list conversation.
What?
Voluntary.
I'm totally fried. I spent like 20 hours or 30 hours or something working over the weekend on crazy stuff. So I'm gonna listen. Although I do have to, I guess, do these pull requests, but I'll be honest, I was kind of phoning it in. I updated the list, but I can't guarantee the accuracy of the new stuff in here. I tried to look, and kind of my eyes were glazing over. The folks, the core meeting was going a little over, so I think a couple people will be here late. Sage is apparently like triple booked, so I don't think we're gonna get him, but at least maybe we'll get Greg and a couple other folks maybe. Well, Matt and Casey, how are things going in the RGW land?
Strong like bull?
What was that?
Strong like bull?
Oh, very good. I like to hear that.
Plenty of work to be done.
Is a beastly bully beast? I don't know.
Yeah, there's Beast stuff. I mean, Casey's work on Beast that Autosoft help with is getting productized in our 3.2 downstream release. So we have people, in other words, it's already upstreamed. It's in Lunas even. So we're going to try to rely on it as the default ACTP, and then on our next downstream release, works going on to redo the thread to the request workflow to be all coroutine based and asynchronous using the same primitives. Adam's helping with that from the Rados side. So we'll have one, so Rados and ACTP will be in a single processing loop without thread handoffs and stuff. There's work going on bucket index reorganization, and I'm working on OMAP, which I hope to list more. You're on the email thread that Brad started for that. I've been sort of looking at revisiting your suggestion to look at Forest DB not as a canned solution, but as a set of primitives that we would adapt. I think there's a lot. I'm writing a paper, a one-pager sort of prospectus on why I think that's a good idea, so that people can rip apart.
I was looking at Forest DB a while back. That was the next thing on my list to write a key value DB implementation for after LMDB.
Exactly. I saw your email about that. So I've restarted that. I mean, I was working on Wired Tiger, but then I discovered that that for a couple of reasons. But one is the license in fact still has a Berkeley DB license that will kill us. I apologize for not noticing that earlier. So I think Forest DB is the most useful sort of canned thingamabob we can start with. I don't think we're going to be able to keep a lot of it as such, but I think the basic ideas in it, the basic stuff is right as a starting point for experimentation. And then, and it's small enough that we can build up that if we did this, we could do the we wouldn't be just spending all of our time managing a giant code base as we try to adapt it into the different form factors we've got. It has had a bit of it had trouble getting an open source community started. But I think that we've reached a point in history that if somebody did that right, that an open source development would circle around it. But anyway, I think you can just sort of prove that LSM is a dead end for us. Probably everybody else.
I kind of generally agree too. I think the where I'm at right now.
I don't know why. The one question I can't figure out is if that's true, why does Keith Bostic spending all of his time trying to write an LSM for WireTiger? I can't think why, but he is.
I don't know. Yeah. The only thing that I wonder though is whether or not if replacing RocksDB actually is worth all the work right now, or if we're better off just trying to make our workload for any key value DB smaller. so that
Well,
what's the best use?
That's what Kung Fu teacher
Yeah,
used to say. Both are acceptable.
yeah,
Um,
I know, but yeah,
but yes, you need to do that. But here's the problem, right? I mean, I guess yes, we have to do that. That's a whole track. That's a whole analytical track. But number one, did we do? Can we have this? We should have this conversation next week because this is the buffer list work.
Yep.
But but if you want to do that, I'd be happy to have my one pager ready for next week, and you can shoot holes in it. But I think that question needs to be considered. But I think yes, there's a bunch we can do. Yes, Intel sort of didn't you already do the PG log PG info takeout?
Yeah, that's basically my.
Did that get done? If that's not done, someone's got to.
Happen, right? Yeah.
Well, someone's got to bloody do that.
Yeah.
Separately.
I shouldn't say nothing's happening. Neha has actually done some really good work on, but it's not that. It's different, but it's.
Well, maybe it helps us, but we need someone needs to do that. And can RGW use OMAP differently? Yes, partially, but not completely. And we still have the fundamental scaling factor of the index of OMAP itself.
Yeah. Anyway, let's talk about it next week. Let's get this thing started, and we'll move on. All right. Like I said, I kind of phoned in pull requests this week. I've been working insane hours, and I couldn't even concentrate on what I was doing. But I will attempt to go over them. So, we've got a couple of new ones in the last 2 weeks. There's some kind of fairly complicated buffer list PR that I didn't even. Well, I don't actually even know if it's complicated, but I assumed it was. So there's that. If anyone wants to look at it, it's actually kind of relevant for this meeting, possibly.
Didn't someone do a vectorized thing?
I don't know if anyone did a vectorizing. Both Radic and I looked at small vector for just replacing standard list, if that's what you meant.
No, yeah, I didn't mean vectorize. That was wrong. That was weird. I didn't mean vectorize.
Sure.
I mean use vector.
Yeah. We both used small vector, and we both saw really similar results where it was slightly slower, and it doesn't make any sense. But yeah, I think to me anyway. But let's talk about it after the rest of these things, and then we've got lots of time. What else? There's some kind of OSD map change in smaller batches in Calc PG on maps. Kifu did this. Is Kifu here? I don't think Kifu's here. He doesn't. Oh no, Kifu is here. What is that? What did you do?
Sorry, what PR are you talking about?
Sorry, this is 23734.
23.
Here, I'll link it.
Okay.
There we go.
23734. Oh, that's one. I didn't look at it closely, but it was reviewed by a ZTE contributor.
Oh, okay. Oh, is this from someone else? Did I screw this up? Okay, here, let me. Yeah. Okay, I have no idea what this does. Well, we can move on. There's another MDS one. Oh, max export size is enforced. Oh wait, no, that's closed. Let's see. Log void heap allocations for most log entries. Oh, this is like an MDS thing, I think. But Casey and Kifu, you guys both reviewed this. Is there anything interesting going on there?
I think it's amazing. Yeah, it takes out a lot of allocations for every D out. I think it's really valuable.
Yeah, it trade the pre-allocated memory with a mem copy. I think it's a win this way.
Yay. Any noticeable effects on the MDS? Like, is it faster or lower CPU or anything?
As far as I know, it was only looking at the heap profile, so it was way less allocations. Mm-hmm. But it is faster in the log unit test for the benchmarks that are running there, quite a bit faster.
Nice. That's good to hear. All right, so let's see. closed. There was another version of this buffer pull request that got closed. That doesn't matter. Okay, yeah, this OSD maps thing. I'm apparently all over the place. That was Kifu's thing. Yeah, another MDS optimization. And then reducing the PG lock granularity in the op reply process. Wow, that sounds scary. But that got closed without comment, so I'm not sure what's going on with it. All right, well, that's it. Well, I guess there's some updated things here. Oh, my cache binning thing. I was really hoping that would just pass and get merged, but apparently Sage got something to segfault. I think it was like TC Malik. It somewhere did. So I need to figure out what's wrong. But most likely it's a bug in my code that I just didn't realize. So it's never segfaulted when I've tested it, but I guess unfortunately, maybe this can be a deeper problem. What else? Shard thread do on commits thing. Kifu's testing it, I guess. I don't know anything about it. That's it. There's maybe some other stuff here that possibly changed in the new no movement list. I didn't quite get all the way through it, but if it is, it's all old stuff I didn't get through. So I doubt that there's actually anything else new in here. So that's it. Before we start on buffer list, does anyone have anything that they want to mention or talk about? All right, Casey, I'm turning it over to you. Have at it.
All right. Yeah, so I guess this came out of a conversation that Mark and I had a couple weeks ago. It touched on some C-star stuff and what they do for zero copy networking. They have a packet class that's kind of similar to buffer list. But we also talked about experiments to replace standard list with small vector. And it sounds like we had some mixed results there. I definitely think it's worth exploring though.
So yeah, the surprising thing to me, right, is I would have thought that getting rid of the double pointer dereference would have just helped in some aspect, right? I mean, you still have these car star fragments all over the place, so it doesn't deal with that. But I guess I figured it would do something, but it seems like in both my tests and in Radix tests, with very similar but slightly different PRs that do the same thing, neither of us saw a consistent win, and sometimes kind of a small regression. Radek, am I characterizing your results correctly?
Yes, you are. Moreover, it's funny thing, because I saw a nice improvement in all benchmark unit tests related to buffer list, but when it came to real workload, well, the results were mixed.
So first. Sorry.
I was just gonna say my very uninformed guess is that we still have lots of fragmentation. Just switching out standard list to small vector doesn't really solve it. It maybe sort of does some minor improvement in some aspects, but doesn't really solve the bigger problem, which is that you've got these car star fragments all over the place. You still have allocations all over the place. You're not really doing any kind of stack allocation for much of anything. So it's it's kind of just throwing a pebble in the ocean, right?
And there could be also another thing, because of the iterator invalidation, we had to change a bit the way how iterators over buffer list works. It might be that it's now slightly costlier. But taking into consideration the huge amount of places we have we are iterating over buffer list, well, it might take any benefits from avoiding unnecessary dereference.
Is that would that validate would that invalidation be the same if we used standard vector as opposed to small vector? Just out of left field, it's the same.
The same.
Yeah, it's
Also, we need to take when copying. When it comes to copying data, well, we need to copy more at the moment.
Radek, regarding iterator invalidation, the path I started going down, which was different than yours, which I gave up on and just adopted what you were doing. The thing I noticed, one of the things I noticed is that we hold an iterator open when we create the encoding at the beginning. You know, if you go and look at like the nasty like encode start and encode finish stuff, we hold an iterator open throughout that like whole thing, right? Maybe even two, I forget, but I wonder if just kind of in general we need to really make sure that we're never holding iterators open unless we absolutely have to.
Well, that's a problem that comes from our usage scenarios for buffer list. Basically, it's used everywhere for everything.
Yes.
This imposes that it must be very, very generic tool, able to handle many situations. So maybe starting from making some difference, putting some more types, more specialized types, starting for instance from the low level encoding, decoding stuff is a way to go. Maybe we could maybe we will be able to just squeeze some requirements from the list.
So Casey, your stuff in C stars. Let's get back to that because maybe that informs us what we could do in non-C star Ceph. Because I briefly looked over that code, but I haven't looked at it really in detail.
Yeah. So C star has this temporary buffer thing, which is kind of like Ceph's buffer pointer, where it's like a owning buffer segment. And then it has this packet class, which is kind of just an array of segments. It's more flexible in what you can put in it, whether it's owning or not. Have some segments with one deleter and other segments with another. When you first construct a packet, you can say how many segments it's going to have in it, so it can pre-allocate and not have to reallocate as you append. So that's kind of similar to something we could do with vector. But I mean, overall, I don't think that our D star OSD work is doing much with D star's packet. We kind of just still use buffer list and convert to and from when we're sending things over the network.
Okay.
So I think we're still kind of stuck with it because we have to support all the encode decode stuff for Ceph types.
Have you looked at all at kind of the feasibility of where we could make use of something like that, or even just, you know, one of the things that's come up in all of this, right, is that like Radek said, we use bufferless for like everything, right? I mean, are there places where we can stop kind of, or we can use more specialized things that
here's two questions. Well, that's a really good question. I have a separate question though. I mean, or a basic one. There were always a few places where we saw there were sort of, maybe I can think of sort of four things. Maybe there's more that where bufferless has interface tensions. with that are different. And we might roll out differently if we used it differently. But one, it's sort of a vector of IOX, but we're using standard list, and so we're allocating stuff. That's what you talked about. That's one. It's two. Whereas on a UIO, classical UIO would be an array of IOVEC. Two, it has atomic operations for doing sharing, which is convenient, but but we're not always sharing, and so we're paying for fencing all the time. Four is that three? I don't know, three or four. It has interfaces that are based on rope that are about squirting more data into buffers and consolidating junk. But I think we only pay for those if you use them. So they invite code to do crappy stuff, or at least crappy stuff for some use. Like we saw this when we were working on XIO Messenger, there were things going on in MDS that Casey found where it was where we were appending stuff and we were kind of dribbling in and expanding buffers, but we were trying to take buffers out and treat them as chunks and put them right in the frame, right in the stream, and that was hilarious because we then had thousands of units as separate infinite band messages. But that doesn't happen unless you do it. So I think that's a rabbit hole. But maybe not. But I mean, for one, in a CSR world, if you don't do that, you're probably better off much of the time. But you change the workflow to achieve that or not achieve that. But in a CSR world, a given buffer list is never going to be shared, or does it ever need to be shared between contexts that need an IPI or fence? Do we ever even need that in a C-star world? Can we just compile that CRUD out?
Yeah, that's a really good point.
No idea.
Then you could just. It seems to me separately. Would anybody be invalidating any iterators in an environment like that? And in that case, or could we just rewrite codes that invalidate iterators in dumb ways? Right. So I guess there's never any. I mean, iterator invalidation doesn't arise from sharing, I assume, across threads or something, right? I guess it's just arising from algorithms that loop through and zap things, and then what if we just change that?
For vector, anything that expands could potentially reallocate and invalidate all iterators. So adding things, even append at the end, could potentially.
But that would only. But again, that could be tuned away.
And it's only while you're mutating it. Once you're done mutating, you basically.
I mean, it feels to me like it feels. My intuition is telling me that the two things could be killing us: validation, like you say, and fencing. I did some work in a Ganesha where I was experimenting with this with basically a version of a sharded. I don't know what to call it that, but whatever. We have data structures that are used by multiple that are used by multiple threads would end up for the duplicate request cache. So it's TCP association specific, but for V3 NFS we have to track every request that's been seen to make sure we're not seeing a dupe. We currently use a B tree for that. B tree is extremely fast when one thread is doing it, even though I had a colleague who told me that wasn't the case. It could do millions of operations per second. But as soon as we try to hit it with multiple threads, it collapses. But I did charting where I was doing page aligned stuff and doing thread doing cache lines, friendly things and so forth. If any threads ever touch the same thing, you lose almost all performance. It's so bad. It's terrible. Well, exactly right. But I mean, I guess my point is that it's so bad. It's much worse than I thought. It's vitiating all attempts. It's actually defeating all the attempts to make all the standard techniques of pointer marking and sharding and things that you think are going to help. If the threads this is the point of C-star. If the threads are sharing the data at all, we're screwed.
That almost makes it sound to me like then in the C-star world we need this to happen basically. We we almost need to make sure that there's every single shard is totally independently.
as much as
Can't
possible.
be
But I had a beautiful model where I could just try everything. I could do 100,000 shards, and we were getting a lot. The benefit was we were paying a penalty even. You could still see the penalty even when I had 100,000 shards. It was madness.
Moreover, the cost is variable. When it comes to having dozen of CPUs touching the same cache line, you are extremely screwed. Let me find a link. There is nice graph in the Linux perf book. Okay. Here it is. Page 57.
Okay. Oh, you can actually read this whole thing for free? How cute. Oh, McKinney. Oh, yeah, Paul McKinney knows where Heavy speaks, doesn't he?
All right,
Cool.
page 57, did you say? Holy smokes.
That's a lot of pages. All right. So,
I know.
but I mean, no. But there's two questions I want to ask for that, because I mean, number one, you got right onto it with your variable cost. We're pessimal now. In C star, will we be optimal? And how much will we pay for a fence?
No.
If we're generating fence instructions, how much are we going to pay if nobody ever touches the cache line? Because that's all it'll be, right? We'll never pay for cache line. We'll never ping pong.
There will be no ping pong, but still on 86, atomical instructions are costly.
Lock instructions in fencing.
Okay, because of fencing, basically, it's any locked instruction is equal in effect to the M fence instruction. It's a instruction that ensures that all your previous loads and stores won't mix with those after the locked instruction. Basically, it flushes store and load buffers in your core. It can be, but still, even there, the cost is variable. If you are doing a sequence of stores that would miss L3, go to main memory, well, fans would nicely expose those things. However, if your store and load buffers are almost empty, well, the cost still be there, but not so big. Maybe related mostly to switching, maybe most likely at the decode phase.
But we're still going to. So basically, though, I mean, would it be hypothetically? Would it be the case that on in the C star like model? I don't know if that's all we care about. But number one, I'd like to look. I try to look for two things. One, can we recover the vector reorganization? Because we want to converge on a usage model for which it wins. If we're sort of like the trace buffer stuff in the MDS, we don't. We pay for that if we use it, but if we stopped using it, if we stop doing things that invalidate iterators, then we just don't have to. Then vector should win a lot in a lot of different ways. Two, if we're on C star, do we need fence instructions? Do we need this at all? So we can so if we just did that, don't we get a huge win?
Yes, we should definitely. We should if we never share buffer list, then going with fencing is overhead.
That should be amenable to just compiling out, I would think.
Yeah, we can absolutely kill the atomics in the C star raw case.
That would be keen.
And by the way, in the matter of vectorizing the list of buffer pointers, buffer list has inside. There is another problem, basically already mentioned by Casey, I guess. if you are mutating the list, then you will have a lot of copies of those data, actually moves of those data. And
But a buffer is of an appropriate size.
Yep. It means that the previous part would need to be moved. It's expensive. We could try using things like SCDQ. I tried.
No, but seriously, the question here I have is, how like is it really the case that our workflow pipeline must defeat our attempts to size vector appropriately upfront, or that the appropriate size is so large that it's intractable to do so? Doesn't it all? I mean, hypothetically, doesn't it all come down to those two questions?
It will be perfect world if we would be able to allocate, to pre-allocate, to reserve the necessary size a priori. That will be the killer feature. However, it might require a lot of rework of currently existing code.
That's the question I've been wondering too.
But isn't that really the goal?
Yeah. I wonder if all of this discussion about everything we've just talked about, how much it actually makes sense if we go back and just look at the code using buffer list, and is it just that we're trying to solve a problem that we shouldn't solve or that we don't need to solve?
Well, I think so. My intuition is that might be true, but it leads in the direction of keeping the vector reorganization.
Yep.
The question, sorry, please go.
I was just gonna say, and even maybe vector is more than we need, right? I don't know. I have no idea, but how often can we get away with something that's stack allocated that doesn't even need vector? I mean, small vector, kind of more or less does it, so maybe we don't care, but.
I think small vector versus vector is a separate issue, and it's trickier. But I think
I'm saying small vector versus, can you have something that's actually stack allocated inside, a container that doesn't even need, a small vector data.
That what small vector does? I mean, isn't that just a choice of?
Saying is that maybe it's a really ridiculous thing to say.
Well, I mean,
already does it.
But I think standard list is the worst, and
yeah,
you sort of shouldn't be doing it. I think deck is almost the same. So I'm interested in. To me, I'm interested in vector resist.
Deck is a lot closer to vector, right, than standard list.
Yeah, maybe I don't know. I mean, it may degrade better as long as we don't pay much for it up front. I haven't looked at that closely. I'd like to see a workflow. I'd like to see us talk about how we could get the workflow such that vector would almost always be correct if correctly sized, and so deck would be buying us nothing. Hypothetically.
Yeah, but that's the best idea we could proceed with. Still, there is a question how to do that. Of course, we can profile, but profiling turns into yet another question. Are we sure what is the typical workload at DC? Do we have tests, benchmarks to replicate that correctly?
Radek, I think that's the $1 million question: is what is the workload that we actually invoke? And maybe I'd say before the testing question, the next question is that workload correct? Like, are we doing the right thing? And then, after that, maybe is the question of what should we be benchmarking, what should buffer list actually do?
That huge degree of freedom when it comes to employing profiling. When it comes to employer profiling.
So maybe part of this, and I have to admit I haven't done anything to resolve this or look into it, but someone should look into how we're actually making use of buffer list and what doesn't make sense, right? We had to do this in Blue Store a couple of years ago, right? We were doing all these small appends and it was awful. and it wasn't necessary. We could pre-compute the size of things and make one big allocation up front. But I have no idea in the rest of the code what is done or is not done, or what makes sense and what doesn't make sense. So
yeah, I think just the fact that it's doing so many different things and we're paying for all of the features every time that we use buffer list. I think we might explore ways to break those responsibilities apart. So having like a unshared buffer list, maybe like a const buffer list once you're done mutating it. But right, we just have so much code that relies on buffer list itself at this point that making changes is a big project.
I like this idea. If we want to profile the most prominent users of buffer list, then we basically can shot two rabbits with the same bullet. We
I mean,
can
by factoring it out, like by lifting out a key workflow into some other type, which we can then arbitrarily improve.
Better specialized, better, just cheaper for this particular user. Or by the way, we not even going outside just the implementation of buffer list, its interface is huge. It's very complicated. We have there zero copy facilities. We have CRC. I don't know any user of the zero copy at the moment. I mean zero copy, not in the term of DPDK.
Exactly. This is zero. I always go ballistic when I have to talk about it, so I'm going to never say it. So I'm not going to say it. I just said that I'm not going to say it. So I'm not going to even discuss that pipe thing.
Yep. I mean the mechanism based on VM splice.
Yes, exactly. It's going to be so useful to us in C star. My friend, kill it now.
So I know that
sounds nice.
I know that Kifu is he's been helping with the C star stuff, and he's also really probably the most knowledgeable about encode decode and the requirements on buffer list. So I'm curious if he has any ideas in that area. Kifu still on?
Sorry, I got distracted. I was willing to watch the recording. I just gave up. So the connection was spotty.
Okay. Yeah, just curious if you have any intuitions about ways that we could change buffer list to get encode decode to work better. I know there's some particular requirements from that.
I see. It was troubling me for a while, and I don't have a wild guess so far. Sorry. The segmentation problem is the most troubling thing, I think.
I was just gonna try to go look at the encode decode stuff. Someone else talk while I figure out what I'm looking for.
Yeah, just idea that I had for decode specifically was splitting like the mutable buffer list into some kind of builder pattern. So you have a buffer list builder while you're actually decoding and adding new buffers and stuff. And then once you're done mutating, you would turn it into something else that that wouldn't have to worry about iterator and validation and stuff.
Well, that would be nice. Let me look.
We can differentiate the two kinds of buffer. One is a mutatable, one is immutable. For mutable, we can copy it out, and for immutable, we just keep it as.
Encode. Okay, here we go. Encode start. This. Go ahead, Radic.
What about converting our current buffer list into a bit more modular thing? I mean, let's take the fencing as an example. Maybe we will be able to have pretty the same building blocks for both C-star and non-C-star workloads. But for non-C-star, maybe we could just put some fencing layer above the same low level component used for in both worlds.
Right. So it's buffer raw right now, the base class that has the atomic reference count in it. And so all the different buffer types inherit from that. My thinking for the C-star converted buffers was to have a different raw that didn't use atomic. And I think that's simple enough. But in the C-star OSD, you're going to be getting buffers from elsewhere too. So stuff that's just allocated with new and deleted with free, like we have in existing buffer, and we would want to avoid ref counts or the atomic ref counts for those also. So maybe when we're building C-star, we just don't use atomic for any raws. Does that make sense, Kifu?
Yeah, by not using ref count, we are not sharing it, right? Is that what you mean?
Well, we'd still have sharing, I think, but we would always be doing it on one core, right? So we wouldn't need the atomic.
Yeah, definitely. Otherwise, we could pass the buffer around between different shards, but we will be using foreign pointer. So the ref count will be living in the foreign pointer, not in the theta or the row pointer.
So I linked. Those are the.
Regarding the reference counter, I think BlueStore has a cache, and we do use the ref counting when we give the data during the read out. If that's maybe that will be the different buffer list, the different flavor of buffer list, but then we would have to copy somehow into that thing, and that's.
Sounds like the cache of BlueStore will just need the fencing, the ref counting layer above.
I kind of wonder in the C-star world if the Ceph cache needs to work differently anyway.
Well, yeah, that's tricky because we say the C-star world where everything is nice and you're only on one core and you don't need atomics, but we're still going to have this alien thing that Kifu made where we have other threads running that do need sharing and do need atomics.
Yeah.
So it's not just all or nothing.
Even we can kill the alien thing, we still need to share the. For example, we need to share OSD map between cores, and we also need to figure.
Well, I was going to say with BlueStore caching, it's clever. You know, the use of intrusive list there makes kind of the management of the LRU cache really simple because you can just like have stuff go away. But it's not. I kind of wonder a little bit if that model is really very friendly for just everything else we've talked about, right? I imagine there's probably a lot of memory fragmentation. There's just a lot of stuff with pointers out to it scattered all over the place. So, it's probably a totally separate discussion that's related, but I don't know. I wonder in the long run if the way that we do caching in BlueStore is really going to be feasible for any kind of high performance workload, really high performance workload. So I guess what I'm saying is maybe don't. It's not necessarily this limitation isn't the only limitation. Sorry, that was it. I did link in the chat for encode start. Those are the two iterators I don't like. I don't know. Anyone care or have any comments? I mean, all we're really using them for there is to basically like shove stuff at the beginning, which is a known length, I think.
I know that there are some complications when working with those iterators in general because they don't really behave like STL iterators, as I recall. It's been a while since I've looked at them, but that's one of the kind of issues I've run into manipulating things with buffer list in general. And some of the comments earlier about this thing having maybe too many hats to wear, I completely agree with. I've done things like change the backing, into different data structures like DEC and vector and so on and so forth, and you can indeed see a difference. But as has been observed, without knowing what our actual kind of expected situation is, it's really hard to make a recommendation on what to use. So I've gone so far as to experiment with making that a template parameter, and working around it with some specializations for dealing with splicing and things like that. But even then, and have gotten that to work, except for the iterators. So all the unit tests pass except those dealing with these iterator thingies. And I kind of ended up getting on other things, so I never had a chance to delve deeper into that. But there is complication directly related to these things. So if we could replace these with things from the standard library, for example, if that's actually feasible, I think it would be a real win, or at least bring it closer to being like an STL container.
So Radic got around the iterator invalidation issue, and I ended up adopting his code. At first, I was actually going on the path of trying to change this and change some other things to just like make it not a problem. But Radic's code actually, he gets around it in a different way, which actually makes it pass. When you're using like small vector or something, it makes it pass all of the tests and it all works. But like we said, I guess at the beginning, it doesn't fix it or it doesn't make it better. It's just, different.
Yeah, we're sort of in the situation where we're kind of hacking around things rather than really addressing the central issue.
Well, we've got like 10 minutes left, guys. Do we?
So are there action items from this? I think it's time for action items.
Let's clean the buffer list interface.
Clean the buffer list interface? Figure out what's in it that we don't need? Is that a starting point?
Okay, I'm gonna go. That's true. I'm gonna go with it. Sounds to me like we would like to see if we could define different paths that used nominally different type. that crazy? I think we
Not
actually would.
not
I think we would actually like. I think there's time in this call we would actually want to do that. And
not
then
crazy.
if we had that, how could we attack the? What would one of the types be for one of the most? What are some of the interesting workflows where we would accelerate and then go and sort of be aggressive in optimizing those?
Matthew, does Radek's idea help get us there by just starting out by like eliminating anything in buffer list that's actually not used or useful?
Actually, no. I mean, it's harmless, but I chimed in because basically no.
Okay.
It's useful and it's excellent for code hygiene, but actually, jumping to another track would allow us to leave buffer list exactly as it is, and we just don't care.
Yes, that's true. But still, it's just easier to think about a less complex thing.
Yeah, I think the process of cleaning out buffer list would help us inventory the different things that we actually need out of it. So that could be useful just in thinking about the problem at a higher level.
Also, we have plenty of buffer row implementations. Maybe not all of them are so necessary.
Interesting, but
Definitely the zero copy one looks like I think we could even should kill.
fair enough. But I mean, since if it's almost never, if a thing is almost never used, you don't pay for it. But I mean, like buffer.
Maybe you pay because of more complicated, more requirements in the matter of interface. Other things need to take care of.
Okay. Well, I guess maybe we need more time to discuss. I mean, but I can think of two or four ways this could go. You know, but to me, it feels like it has a lot to do with the context. C-star allows aggressive optimizations, and we jumped to it. We took the sort of railroad track switching approach to go to C-star. Or tried to take the previous approach of saying let's build a lock-free OSD, and if necessary, we'll change the semantics of Rados to make that actually legal to do that. And when you had the C-star is better. It's more because it solves the cache line problem and allows us to scale to more dies and more cores in the same way. It handles NUMA effectively, and we can't handle it. We couldn't handle it with core, but we could get with a small number of cores on one die. We could definitely get a lot of wins with lockless. Lockless would let you then So it feels. What I'm saying is hypothetically, can you really get any big wins? Haven't we already got counter evidence that we can get a lot of big wins by changing how buffer list works, or any of the primitives work, if we can't change the workflows, whether it's iteration or fencing or whatever. If we can't change the workflows, then could we just avoid worrying about that and focus on an execution path where we can? Or is there something we could do to the workflow in the regular and the non-C-star OSD that would get us big wins up front? What would it be?
So I'm a big fan of letting people just work on whatever they're interested and passionate about. Radek, if you want to clean up buffer list and make it like easier to read and easier for us to even have this discussion, I would encourage you to go do it, because no one else is and no one else has.
Sure, why
not? Is that something that you'd even have time to look at, Radek?
I was taking a look on buffer list, mostly because of the small vector try, and also DQ. I would love to kill unnecessary things there.
Well, like if you're, I mean, did you essentially propose too that, I mean, you hinted at it. You brought me conceptually almost to the point where I thought you were saying, could we eliminate, like, if we can eliminate fencing, C-star can give us that. Is there any point in even talking about that for non-C-star? Is one question I have. Two, though, is all workflows would benefit from vector if we could eliminate the validation problem. Is that practical?
I'm really afraid about the code base. We have so many very different users of the buffer list that moving everything in one single shot looks to me like possible. If you want to change the workflow, how we use actually the buffer list, I guess we should start from step-by-step method, maybe based on profiling, just to figure out the most prominent things. Well, when it comes to RBD, the case is pretty straightforward. You are running or rand writes or rand reads with appropriate block size, and basically most or less it should resemble what people do, what typical, I hope, workload looks like. I have absolutely no experience with performance testing of RGW. I know we have cost bench, but how far or how close it really is the let's say abstract typical average workload in DC, I have no idea.
And even less idea how much of an impact buffer list itself has compared to other overhead in RGW.
Yeah, haven't profiled RGW yet.
I also wonder I wonder in the OSD how these different things have compounding effects on each other, right? Like it might be that solving buffer list doesn't do much until we solve other things. So I don't have no idea.
Mark, in one case, it already did. It was the transition to OpenSSL, from NSS to OpenSSL. Basically, the PR made two things: switch the library, but also killed buffer list at all on the Ceph XPath. There are some numbers, some outputs. Well, it was worth several percent, maybe even more.
I completely believe that. After I replaced buffer list in the mem store with a vector implementation, it was ridiculously faster. It's, yeah. All right. Well, so maybe that's the kind of thing, right, Radek, where we had a specific situation where you could do something like that. You could look at it and say, this is crazy what we're doing, and let's do it in a better way.
But we're solving it by getting rid of buffer list effectively, or using different types that do something similar to what a small fraction of what buffer list is doing, right? Isn't that an example of not changing the buffer list interface, but sidestepping it?
Buffer list was simply too expensive to use on such hot path. Just too expensive. Not surprisingly, simplicity won.
Are you talking specifically about the crypto interfaces around buffer list?
Yeah, around them. We stay with buffer list based interface for most of the things, but switch to non-buffer list one. Basically, old plain buffers for the Ceph XPath.
Yeah, one thing that particularly bothered me about the crypto stuff was that they called CSTR on buffer list. So if there were multiple segments, it would have to reallocate in order to get a contiguous buffer.
I think that's actually what was going on in the mem store too, with the buffer implementation. If I remember right.
Yeah, but even the costs of buffer list creation are not so small. If you make it over and over, well, it will be in the profiler output.
We've run out of time, guys. So I guess next question is, does anyone plan to do anything, or are we punting for now?
Well, I'll certainly follow up with Kifu on what we can do on the C-star side. The first step would be getting the atomic out of the C-star specific buffers. I think that's safe to do. and then we'll have to look at how alien threads can handle that.
Sure.
I would love to join that effort and share something still something different, but still C-star related. Josh asked me to take a look on the LTTNG in the spot of C-star. At the moment, it's work in progress, basically a background one. But I hope I will have a paper on the beginning of at the beginning of next week.
Yes. Riddle, probably I will reach out to you later on over
Sure.
IRC to sync up with the progress on the LTDNG blogging.
Perfect.
And I would still like to explore small vector. I think that
basically we would need to. Well, that's the thing we want to make with to take a look on with Mark for weeks. We would need to figure out with profiler at assembler level why it's costlier in some scenarios. Because at the moment we made a lot of speculations. Maybe because it's maybe it's because of the mutation. Maybe it's because of the extra cost of invalidate extra cost related to iterator invalidation. Who knows? We need to be sure.
I might point out that Mohammed Gabi has done a fair amount of work benchmarking buffer list. You might reach out to him.
Cool.
And also, I'm extremely excited to see some work in this direction. This has been kind of a personal bugbear for a few years, so I'm excited.
Well, yeah. Hopefully we'll make progress, but we'll see how it goes. But I hear you. It's been kind of a, well, I don't know. It's been there, right?
Whatever we come up with, can we please not call it either buffer list or buffer : list? And definitely, can we please not alias the type buffer list to buffer : list? Just wish list item. Thanks.
You, Jesse, that said that?
Yes, I'm sorry. This is Jesse Williamson.
Yep. Okay.
Sorry.
I'm noting your concern.
That's a little tongue-in-cheek, but somewhat serious, actually. It took me a while when I first started hunting it down to find the implementation. It was a bit of a head-scratcher at first.
All right. I think we're out of time, guys. We've beaten this to death. So, all right. Well, we don't have any real action items other than the CSAR stuff that Casey mentioned, but maybe that's a start.
Well, there should be. I don't agree. I feel like we should try to. Well, we can. I don't know who can do what. I mean, but there ought to be the work by Radoslav and other people to do the vector stuff should not die. We should keep pursuing that and follow out Radoslav's proposal to better understand where it falls over and try to get to a point where we can just use it, if not for all workloads, then to propose it as an alternative for some workflows, because that seems like that.
I've got some action items listed on the Etherpad, but right now the only one that I've got anyone volunteering for is the C-Star stuff with Casey, Radek, and Kifu. But I don't think anyone else is. Yeah, no one else has volunteered for anything. So if you've got people that you can put on it.
We've done this work before. We've done this over the years. We did a lot of work, a lot of junk efforts with buffer list replacement over the years. I'm not convinced that we can do it. We can solve the general problem, but it seems like Radoslav already was. I mean, I do sense that this is. I've already got. I already feel like I've got enough battles to fight as far as OMAP goes, and it's shaping up to be a big battle indeed.
Yeah.
I feel like, nevertheless, I feel like Ron's on the right track here. I think Jesse is saying endorsing that too. It's not. The challenge is the challenge really is, as I see it, the challenge really is that there are two or three. We don't know what all of them are. We know what some of them are. The threading model is one of them, and other aspects of the non C-star OSD workflow that are going to make that are going to make it challenging to get big wins out of speeding up bufferless alone.
Yeah.
I don't know if we care, but there's still huge wins to be had there if we're able to concentrate on it. I don't know. I mean, does anyone? We can't waste time talking about this to some extent, but if we did want to waste time talking about it, how many years will it be before the first operational site using C-star goes live? Or more appropriately, how many? And even when it does, how long before C-star OSDs can remove legacy OSDs from the field?
Yeah.
Is that I don't know, but
it's going to be a while. Well, that's my take, but I don't know. Matt, next week we will have a very good conversation, I think, about OMAP, because I imagine that we have a lot that we agree on. And also, I
Yep.
really want to get PG log out of OMAP's way and out of your way. I think that'd be a really good idea, but we'll talk about it more later. So have a good week, guys. Well, I'm sure we'll talk about this more.
Thanks, Mark.
Thanks, Mark. Thanks, Russell. Thanks, everybody.
Mark.
Have a great week.
Guys.
See ya.
See you.